just what it says. Second
Lock it when you come back in,
second
right?
semester practice.
So it doesn't become part of the house. Just lock it when you come back in.
Well, you gotta open the drum. Give me 1 sec, you guys. Okay. Sorry about that. Let me keep going here. So number 1 says graph the line y equals negative 3x minus 1. You caught that, huh? Thought I muted myself. Y equals negative 3x minus 1. So, I would, well, just remember when a line is in the form, the equation of a line, that is, when the equation is in the form y equals mx plus b, and, well, when it's in that form, it's easy to graph, and all I really do is begin and move. Begin and move, right? B for begin. B is negative 1 in this case. That's going to be down 1. And then M, your movement, is negative 3 in this one, which make it a fraction by putting it over 1. And it basically tells you how to move. Negative 3 over 1 is down 3, right 1. So, I can begin at negative 1, which is down 1, so begin there. And then my movement from there is down 3, right 1, so down 1, 2, 3. Again, that was begin down 1, and then move down 3, right 1. Hopefully you remember that from, this was closer to the beginning of the semester, but either way, you only need those 2 points to draw the line. So that's all you have to do for the first one. Begin and move, right? If the equation is in the form y equals mx plus b, that's not too bad. Number 2 now. Number 2 is graph the exponential function f of x equals 1/2 to the x power. So that's, we always did these like this. We always made a table. Again, this was back closer to the beginning of the semester, but we made a table. And in that table, the inputs were always negative 2, negative 1, 0, 1, 2. The x values, that is always negative 2 through 2. All the integers from negative 2 to 2. And we would plug those in and calculate the output, or the y values. So, I already put a 0 there. I guess I'll just do 0 first. I didn't mean to do 0 first, but since I accidentally did, I'll just do 0 first. So when you plug in the 0, right, you plug in a 0 where x is. You guys probably or hopefully remember that all the work, right, all the work happens on the right side. The left side is just the way you note that this is a function, right? F is a function of x, right? I plug in x, and x, whatever goes in for x, kind of decides, or helps calculate what the output y is. Anyhow, all you need to know is when you plug in a number for x, you put that number wherever x is, and you only really calculate on the right side. Here, guys, anything to the 0 power, remember that? Anything to the 0 power is 1. There's that. And then, keep going, right? After that, I'm going to go back and plug in the negative 2, right? F of negative 2. And I'm using the same original function every time. The original function, f of x equals 1/2 to the x power. I plug each of these 5 numbers in and calculate 5 different outputs. So here what you want to do is flip the fraction. Flipping the fraction makes the exponent turn positive. Anytime you guys have a negative exponent, you can flip the base, and that's what makes the exponent turn positive. So 2 squared, 2 times 2 is 4. When I plugged in that negative 2, now I can plug in that negative 1, right? So f of -1 equals 1/2 to the negative first power. This will be the same as the last one. I'll flip the 1/2 and make it a 2, and in doing so, the exponent becomes positive, and 2 to the first power is just 2, right? Anything to the first power will remain unchanged, and then we'll have, plug in a 1. F of 1 equals 1/2 to the first power. Well, 1/2 to the first power is just 1/2, so make sure you're filling in your table as you go. And then we have f of 2. Well, f of 2 is 1/2 to the second power, which is simply 1/2 times 1/2, which is 1/4. Okay? Oh shoot, got off screen there. It's 1/4. We plug that into our table, and we're basically, I mean, as long as we have a few points, we're ready to graph, but you know, we're going to try to stick with these 5 points, -2, -1, 0, 1, 2 as our inputs, and then calculate the outputs based on those inputs. So I have, let's see, I have -1, -2, I have +1 and +2. I also need to be able to go up 4, so I'll kind of mark some of my main values. Right? X and Y axis. We're ready to graph this. -2, 4, guys. The first point, -2, 4. That's -2 spaces left, right? That's negative is left, and then 4 spaces up. So left 2, up 4. Left 2, up 4 lands me about there. And this next point, -1, 2, left 1, up 2. Left 1, up 2 lands me there. And the next point, 0, 1, stay in the middle but go up 1. And then the next point is 1 and 1/2, so that's right 1 and up 1/2 space. And the next point, 2, 1/4, that's right 2 and up 1/4 of a space. And just like when we first did these months ago, it is a curve. Exponential function should definitely make a curve like this. Remember this line that it'll never actually get to 0. It'll get closer and closer to 0 and never actually touch it. So remember that line is called the asymptote. I don't know, this may not come up in the final, but that's what that line is called. It's called the asymptote. And again, this dashed line I drew in is the line that the graph approaches but never actually touches. In this case, y equals 0 is the line, but it can move around, right? If you look in the next one, the asymptote is in a different place. So let's see here. See, the next one has an asymptote down at -3, and let's see what this one says. The graph of an exponential function is shown in the figure below. The horizontal asymptote is shown as a dashed line. Find the domain and range. Well, guys, the domain is simply, right, the domain is simply the x values, right? Like, what are all the possible x values, which you guys can interpret as how far left and how far right should this graph, or will this graph go, right? So that's kind of what you can think of when you're asked what's the domain. You're basically being asked how far right and left will this graph go, or can this graph go, or exist, right? How far will right and left will this graph go or exist? And then your range, right, is your y values, and that's basically this almost the same question, but it's how far up and down will this graph go? How far up and down will this graph go? Sorry, I'm just using quotation marks here so we could save a moment. How far up and down will this graph go? That is your range. So anyhow, domain and range are not super complicated, but But you do have to think about, okay, will this graph keep moving to the right forever? And the answer is yes. It's moving up, but it's also moving right. And will it keep moving to the left forever? The answer is yes. This graph for the domain will go from negative infinity to infinity. Or you can just say all real numbers if you like that better. Again, it'll go from negative infinity to infinity as far as the domain. So again, the domain is all real numbers, which can be stated differently as it's from negative infinity to infinity. The range, I couldn't think of a great way to name it other than saying this. Notice how I wrote down the range as how far up and down the graph can go. The graph will go up forever, up to infinity, but how far down will it go? You can see the asymptote is at -3. It'll never get to -3, no matter what this graph does. Y is always greater than -3. That's your range. Your range is that y is greater than -3, meaning from -3 to infinity, basically. Well, it can't equal -3, but you know, anything greater than -3, which of course will go all the way up to infinity. So that's your range and domain. I don't want to talk it too much. It's not that complicated, and you could let me know if you have any questions. Moving along here to number 4. Number 4 is the triangles below are congruent and the corresponding parts are marked. So for number 4, you can just go through the markings here for this one, guys. Number 4A, it says angle A is congruent to. And you can just look at angle A and see how it has one arc mark. Find the angle that has one arc mark here, and you'll have the angle that's congruent to A, so it's X. Then angle B is congruent to, and once again, angle B, look at it on the diagram, it has 2 arc marks. So find the angle in this triangle that has 2 arc marks, and you'll have the one that's congruent to B, so that's angle Z. And then same thing for angle C. Find it, identify how many arc marks it has, and then you'll know by the arc marks which one is congruent. So angle C has 1, 2, 3 arc marks, and that is corresponding with or congruent to angle Y in this case. Now the sides. Part B is, the side is AB, then AC, and then BC. Once again, for the sides, I'm just going to use the marks to fill in the blanks. Right, AB has 3 marks, and then XZ has 3 marks, so that's the corresponding part there. And then AC has 2 tick marks, so that's going to match up with XY, because XY also has 2 tick marks. And then BC has 1 tick mark, and then that will line up with, or match up with ZY. It also has 1 tick mark. So there's that. And then answer choice, C. C wants us to write the triangle congruent statement. It says triangle CBA is congruent to triangle blank. And let's see what that is. Triangle CBA. It looks like it's YZX, but like without even looking at in too much detail, CBA looks like it corresponds with YZX. But I wouldn't do that. I'd look at the markings to make sure. So look at CBA. C has 3 arc marks, B has 2 arc marks, A has 1. So 3, 2, 1. 3, 2, 1 is kind of what I would be thinking as I name the other one. Again, CBA, 3, 2, and 1 arc mark. If you go 3, 2, and 1 arc marks, it is YZX as predicted, but you definitely want to make sure. Oops, YZX. YZX is the right answer. Also, the answers are at the end. If you just are plugging ahead and you want to check answers, you can do that. These ones right here, we're checking to see if we have congruency, and if so, what's the congruent statement and which congruency theorem applies. So if you look at the first triangle, it looks like side angle side, and so does the second one. They both look like side angle side, so we do have congruency by side angle side. So again, for number 5A, definitely congruent by side angle side, and then we'll just fill in the statement. Triangle GHI is congruent to triangle. Well, if you look at the layout for the way the order in which it's named GHI, the corresponding way to name this triangle over here, make sure I go over those 2 tick marks is kind of what I'm looking. So when I go GHI, it's blank. That's the side is blank with nothing on it, no marks. And then over to I, and when I trace from H over to I, there's 2 marks. So when I name the second triangle, I'm trying to follow this pattern of blank side, then a side with 2 marks. So that would be J, I believe that's an L, JLK. B looks like side, side, side. All 3 sides of one triangle are congruent to all 3 sides of another triangle. So congruent by side, side, side. And then we have triangle MNO is congruent to triangle blank. Well, if you follow the pattern MNO, you see it's 2 tick marks, then 3 tick marks. Again, that's M to N to O. I'm tracing over 2 tick marks and then 3. So that's kind of what I'm thinking when I name the other triangle. 2, 3. So when I name this other one, 2, 3, it looks like PRQ is the correct order to name it in. PRQ, and then C. I know I'm going kind of quick, but you may have to study this stuff a little more to ace it. But either way, these 2 triangles don't look like they're marked the same, and they're not. ABC might have worked as side angle side, but this one doesn't. Side angle side would prove that 2 triangles are congruent, but the second triangle DEF is not a side angle side setup, so it can't be side angle side. So these are not necessarily congruent. Even if you look at this DEF, it's angle side side, and angle side side doesn't prove 2 triangles are congruent, at least not always, so we wouldn't be able to use it. C is a not necessarily congruent one, because the 2 triangles don't have a common theorem like modeled there. Not necessarily congruent. Off to number 6. Number 6. Number 6 is a triangle with, I'm just save us a moment here, guys. Number 6 is a triangle with all 3 angles marked, and it wants us to find the measure of each angle. And so here's the first thing we have to know is the 3 angles inside of a triangle add up to 180. So 5x plus 3x plus 1 plus x plus 8 equals 180. Right, again, that's just knowing the 3 angles of a triangle add up to 180, and there's the equation. And then if you solve this, right, you have 5x plus 3x, that's 8x, plus 1x is 9x, and then we have 1 plus 8, that's 9, so 180, and then we just can solve that. Let's go ahead and subtract 9 to get 9x equals 171. Now divide both sides by 9. And that should be exactly 19. Now use a calculator as needed. So x is 19, but then you're not done. This problem didn't say solve for x. Said find the measure of each angle, so angle M is 5x, so that's 5 times 19, and then angle K is x plus 8, so that's 19 plus 8, and then angle L is 3x plus 1, so that's 3 times 19, plus 1. So let's go ahead and calculate these angle measures using this information. Angle M, 5 times 19, that's 95 degrees. Angle K, 19 plus 8, that's 27 degrees. And then angle L, 3 times 19 is 57 plus 1 is 58. So there's your three angle measures. Again, I'll just recap it quickly. It's three angles in a triangle add up to 180, so you can write this equation and solve for x. Once you get x is 19, you can use that to plug back in and find the actual angle measures as seen here. And then if you add these three angle measures up, it totals up to 180, which it has to. Alright, number 7. Number 7 is the first three terms of an arithmetic sequence. So we have 11, 18, and 25. And the fact that it's arithmetic, guys, tells me it's adding. Once they use the word arithmetic, I know it's adding the same amount each time. You can either kind of mental math figure it out, or you can use a calculator and subtract in reverse order to figure out it's adding 7. Find the next two terms. Well, 25 plus 7 is 32, plus another 7 is 39. The next two terms, 32 and 39. Excuse me. Number 8. Number 8 is the first three terms of a geometric sequence are as follows: negative 10, 40, negative 160. Once again, they tell me it's geometric, meaning they're telling me by saying it's geometric, they're telling me it is multiplying by the same amount every time. To get the next term, you can either divide in reverse order. Negative 160 divided by 40, 40 divided by negative 10, or just mental math figure it out that it's multiplying by negative 4 to get consecutive outputs. So negative 160 times negative 4, I want to use a calculator for that. 160 times 4, and it was a negative number times a negative number, so it'll come out positive. But then 640 times negative 4, that will definitely be a negative number, negative 2,560. Those are the next two terms in that geometric sequence. Again, you could either mental math figure out what's going on, or you can divide in reverse order. And then we have, hold on one sec. Actually, I'll just keep plugging along here. Number 9, it's to simplify the square root of 45x to the 6th. So this is getting a little closer to what we've been working on lately. Number 9, simplify the square root of 45x to the 6th. Well, you may remember that you can just take the square root of x to the 6th by cutting the exponent in half. It's x to the 3rd. But what about the 45? That's something you might want to break down. It's 9 times 5, and 9 is 3 times 3, and it's completely broken down here, so that's all you can do with it, 3, 3, and 5. And then look for pairs of numbers, right? Any pairs of numbers, you can keep one and cross one out. Keep one outside the radical and cross the other one out. And then this 5, it doesn't have a pair, right? It's all on its own. Any numbers that don't have a match go back inside the radical. Okay. Number 10 is rationalize the denominator and simplify. Okay, we have again number 10, we have the square root of 3y divided by the square root of 7. So in case you don't recall, remember the skill of rationalizing the denominator, that is getting rid of the radical. Rationalize the denominator means get rid of the radical, and the way you do it is by multiplying the top and bottom by that radical. Right? So if you multiply square root of 7 times square root of 7, you may already know it's going to be a 7, but if you say square root of 49, you can then take that square root, and the square root of 3y times the square root of 7, well, multiply 3 times 7. It's the square root of 21y. So we have the square root of 21y in the numerator, and the square root of 49 is 7. That's in the denominator. That's all you need to do for that one. Again, rationalizing the denominator means getting rid of the radical in the denominator, and that requires multiplying the top and bottom by that radical. And Let me get those last two in here. I'm going to have to flip the page. Okay, so number 11. Number 11 is, simplify this. 11, I'll just wrap these up. Hopefully you can stay for this. Why did I write 11? It's number 11. It's not 11. It's 5t squared minus t minus 6 plus 7t squared minus 4t plus 2. And this is just combining like terms. Simplifying this is just, it's like the lesson we did last week, adding and subtracting polynomials. So 5t squared and 7t squared minus t, minus t and minus 4t, and then we have minus 6 and plus 2. Those are like terms. So 5 plus 7, that's 12t squared. And then negative t minus 4t, that's minus 5t, and negative 6 plus 2 is negative 4. Sorry, I'm going fast because we're out of time. I'm going to do the last one, so hopefully you can stay for the last one. The last one, 3a minus 5 times 5a plus 1. And I'll just remind you again, this is exactly like what you'll see on the last quiz, which I'll open Friday and it'll be open for 5 days. So you guys can use FOIL, multiply the first terms, and then the outer terms, FO, and then the inner terms, I, and then the last terms. You could use FOIL, or you could use a box to multiply 3a minus 5 times 5a plus 1. So whether you use FOIL or a box, you're still going to multiply 3a times 5a, that's 15a squared, and you're still going to multiply 5a times negative 5, that's minus 25a, right? You're still going to multiply all these same amounts. Still going to multiply 1 times 3a, that's 3a, and you're still going to multiply 1 times negative 5, and that's minus 5. And again, whether you do FOIL or box method, you still end up with some like terms here. Negative 25a plus 3a, that's negative 22a. The 15a squared comes along for the ride. The minus 5 also comes along for the ride. And that is it, guys. We're a minute past due. Your answers are all down here. I will be posting a video of what I just did. But yeah, let me know if you have any questions. And if not, you're out of here. Got another school day.